So on to the last of the angles lessons. We're just going to start on the unit circle concept, which is fleshed out more in Math 30-1 and is used quite a bit for the trig unit in 30-1. So you can think of this as a unit circle, or you can memorize the two special triangles, technically three, but you can cut it down to two. So if they gave us this triangle here, so they gave us the sides of 1 and 1, and they gave us an angle of 45. If we found the hypotenuse, that'd be 1 squared plus 1 squared, which is equal to 1 plus 1. And that gives us a radius here of the root of 2. So now writing out our sine, cosine, and tangent like we did in the last lesson. Sine is opposite over hypotenuse, so root 1 over 2. 1 over root 2. Cosine is adjacent over hypotenuse, so 1 over root 2. And tangent is opposite over hypotenuse, so that's 1 over 1, which is 1. But again, remember we said that rationalizing our denominator is the better way to do that. So 1 over root 2 is going to turn into root 2 over 2 for both of these. And then if I look at my next question here, they've given me a 60-degree angle, so, and a radius of 2. So determining the length of the altitude, it does say it's an equilateral triangle, so this is 2 and 2, and that would make this side 1 and 1 for this one. So if I went to find my side here, it'd be 2 squared minus 1 squared. So that's 4 minus 1, and that would give me my height as being root 3. So then being able to write our sine, that would be root 3 over 2. Our cosine would be root 3 over 1. Or sorry, our cosine, would be 1 over 2, adjacent over hypotenuse, and then our tangent would be root 3 over 1. And then looking at our last triangle, which is doing a 30 degrees, which the 30 degree is just the other one flipped on its side. So for this, it's 2, 2, and this would be 1 and 1. And we already found the side from the previous one, so this is root 3. And now we're just writing our sine, cos, and tans. That become 1 over 2 for the 30 degrees, root 3 over 2 for the cosine, and root 1 over root 3, which remember we like to rationalize our denominator, so that would become root 3 over 3. And those are the three special triangles you need to memorize: the 30, the 45, and the 60. We use them with a radius of 1, but then because we've rationalized the denominator in all of these, we actually switch the radius to 2. So again, here they are just done down to a radius of 1, which is a unit circle triangle, because a unit circle only has a radius of 1, and they give us those values all the time. So just writing them into this chart, so if you wanted to, you can memorize this chart. Sine of 30 is 1/2. Sine of 45 is root 2 over 2. And sine of 60 is root 3 over 2. If I did my cosines, cos of 30 is root 3 over 2. Cos of 45 is root 2 over 2. And cos of 60 is 1 over 2. And then doing my tangents, my tangent of 30 is root 3 over 3. My tangent of 45 is 1, and then my tangent of 60 is root 3 over 1. So again, you can memorize that table if you want. That is the special triangles, so the 30, 45, 60 triangles. And then you also need to know the zeros and the 90s. So sine of 0 is 0, cos of 0 is 1, and tangent of 0 is 0. And then if I did my 90s, sine of 90 is 1, cos of 90 is 0, and tan of 90 is undefined. And the reason tan is undefined at 90 degrees is if you think about the triangle we'd have at 90 degrees, when I have my 90-degree angle there, I have no adjacent side. I only have an opposite side. So when I go to do this, I would have 1 divided by 0. There is no adjacent side. And I can't divide anything by 0, and that is why that value is undefined. So anytime I have a 90 for tan or 270, it's always going to be undefined, and that's because I'm dividing by a 0 value. So going in now, they've made this table involving the zeros and the 90s, so you can go and memorize this one if you want the zeros and the 90s as well. So that's 0, 1, 0, and that was 1, 0, undefined. And then we have our previous chart, so sine 30 was root 3 over 2, then root 2 over 2, and then 1 over 2. Sorry, no, these are backwards. Sine 30 is 1 over 2. Sine 60 is root 3 over 2. And we'll just go back to the previous chart. One, two, three, 1, 2, 3. Yeah, no, it is 1 over. This is right. And then cosine, this is root 3 over 2. This is root 2 over 2. And then this is 1/2. And then going on to my bottom here, this is root 3, this is 1, and this is root 3 over 3. So that gives us our values for this one. So you should memorize the chart or memorize the unit circle. The unit circle is coming up in a couple pages. But if I use that chart now and I find my reference angles, as long as my reference angle is a value on that chart, I can find these answers without actually having to plug them into my calculator. So the reference angle for 210 is 210 minus 180. So my reference angle is 30. So if I look on my chart for sine of 30, it's 1/2. And then if I use my cast rule, this lands in my third quadrant where tan is positive, so this would give me a negative 1/2 for my sine of 210. Because my reference angle says it has to be 1/2, and the third quadrant states it should be negative. So if I look at my reference angle for cosine at 300, that would be 360 minus 300, giving me a reference angle of 60. So if we look at our chart up there, a reference angle of 60 for cosine is 1/2. And then I'm in my fourth quadrant. So this would give me a positive answer. So cos of 300 is equal to a positive 1/2. And then tan 225, if I'm looking for my reference angle, that would be 225 minus 180, which gives me a reference angle of 45 degrees. And then sticking that on my chart, that lands in my third quadrant where tan is positive. So tan of 225, looking at my chart above, 45 degrees has a value of 1. So this would have an answer of positive 1. So that's how we can apply it to find the values where our reference angles matches something on our chart. If our reference angle is not a value on the chart, then I'm going to have to do it the old-fashioned way and inverse it to figure out my value, and then use my chart to go from there. So if it lets me flip to the next page here, we can figure out the next questions. So on to page 4, we have, they want us to find the angle. So with this one, we're looking for root 3 over 2. If you remember, root 3 over 2 is at 30 degrees. So from our chart on the previous page, our reference angle for this is 30 degrees. And then we'd have to figure out using cast rule, where is it going to be a negative value. So cosine is negative in both the second quadrant and the third quadrant. So given that those are my reference angles, my 1 is going to be 180 minus 30. So I have one of my answers is 150. And my other one would be 180 plus 30. So my other answer for this is going to be 210. So those would be my two answers that would give me a negative or a cos of -1 or √3/2. For tan is undefined, that reference angle is 90. So there are two possibilities where my reference angle is 90. One of them is right here at the 90, and one of them is right here at the 270. So my answers for this are just 90 and 270. So now it says I have a point -3 and √3, and it's on the terminal arm of my angle. Without using any technology, complete the question. So they want us to draw it on my diagram and then mark it. So -x, +y, puts my point there. -3 and √3. So now it wants me to state the values of x and y. So x is -3, y is √3. So tangent, which is y over x, would be √3 over -3. √3 over -3. So given that as my angle, that is a reference angle. That is the reference angle for 30 degrees. And then I would have to find that. And since they gave me a specific point, I only have to find the one angle. So that would be 180 minus 30, which gives us an answer for this one of 150. I don't have to find the other one where it's negative just because they gave me the point at -3√3. So I do not have to find my quadrant 4 answer. If they give you the point, use the one that they have the point for. Don't worry about the rest. So going on to the next page. Here's my unit circle. So if you prefer memorizing this as a unit circle, you can do it as that over the triangles or the chart. And to do this, it always works out the same way. You only actually have to measure a quarter of the circle because the rest are all the same answers. They've just flipped on the axes. And the way it always works out is that you've got your regular points on your axes. So this would be 0, 1 up here at your 90. So this is 0 and 1. And then down here at your 0, that's 1 and 0. And then I always have the same angles. So 30 degrees, 45, 60. And then when I go to write my fractions, everything is always over 2. So all of the bottoms of these fractions are 2. What changes are the top. And the tops actually count down. So I'm going to start here at 60 degrees on my x, and I'm going to go 1, 2, 3. And then I'm going to go over 1, 2, 3. And then my tops are square rooted. You can square root the 1 if you want, but the square root of 1 is 1. And that gives me all of my values for each point. And then the other important thing to note about this is that your x point is always going to be your cos answer, because cos uses your adjacent value, which is always your x. And your y point is always going to give you your sine answer, because that uses your y. And then if you wanted your tan values, you'd have to memorize the tan values separately. So the tan values go √3. So √3, 1, and then √3/3. And then for this one, it's 0. And then this one is undefined. And that's your basic unit circle. So we've written the stuff on the unit circle. I'm not concerned about you going and writing the lengths. Here's the whole unit circle with all the values for sine, cos in all 4 quadrants, as well as the points marked down for the y's and the x's. So in the unit circle where r is 1, we have sine is equal to y, because y over 1, and cos is equal to x, which is x over 1, and sine tangent, which is going to be on your Math 30-1 formula sheet, is sine over cos, which is y over x. So then moving on to the next section here, we have page 7. So using the unit circle, find the exact value of the trig ratios for a rotational angle of 240. So again, for all of these, I need to find my reference angles. So my reference angle here is 60 degrees. My reference angle here is 60 degrees. And my reference angle here is 60 degrees. So writing out just my unit circle right here so I don't have to flip my pages and it's extra practice. I have 60, 45, 30. I have everything over 2 for my fractions. And now I count up. So 1, 2, 3. And I go across 1, 2, 3. And everything is square rooted. So going to a reference at 60 here, I have 1/2 root 3 over 2. I'm looking for my sine, so that's root 3 over 2. And then I can't forget about cast rule. So because 240 is in my third quadrant, this is going to be negative. If I look at my 60 reference for cosine, that's 1/2. Again, I'm in the third quadrant where tan is positive, so this answer is going to be negative. And then my tan, again, you're going to have to just memorize this. That goes root 3, 1, and then root 3 over 3. So because I'm looking at 60, this answer would be root 3. It's in the third quadrant. Tan is positive there, so it'd be a positive root 3. For this here, I'm just going to find my reference angle. So my reference angle here is 45. So going to my unit circle at 45, my first value is root 2 over 2. And then again, using my cast rule, so CAST, 135 falls in the second quadrant, making this answer negative. If I look at my reference angle here, my reference angle is 60. So looking at my unit circle for 60, my tangent is root 3. So that answer is root 3. That falls in my second quadrant, making it negative. Sine 180 falls on my my grid itself. That gives you the point of 0 or 1, 0. So my value here is just 0. And then 10 to 70 falls on my top quadrant, which are my 90s. This has my reference of 90. So this one is undefined. And this would have your reference of 0. Looking at my next example here, I've got a point, so I need to put these points on there and then figure out what my reference angle is. So root negative, positive, we'll put my point right there. So negative root 2 over 2 and root 2 over 2. And that on my unit circle does give me an angle here, reference angle of 45. And then I have a negative, negative. So I'm down here for my next point. So I have a negative 1/2 and a negative root 3 over 2. And looking at my unit circle for that, that gives me a reference angle of 60 degrees. And again, you can just look up at the unit circle to match those up. So now it says if the object rotates counterclockwise, so counterclockwise, so I'm rotating counterclockwise from point A to point B, what angle has it rotated? So I'd have 45 plus 60, and that would give me 105 as my angle. Use a calculator to determine at 4 decimal points the coordinate of a point on the unit circle that corresponds to a rotation of 145. So with 145, I'd have to go into my calculator, and I'd want to do my sine and my cosine. So I'm going to go second sine of 148. Oh, was it 148? 148. So I'm going to go second sine of 148. because that's going to give me one value. That gives me value entry is not allowed in the function or command. Let's see what I did. Second sine of 148. It won't actually let me do that. I'm going to have to, never mind, not second sine of 148, just sine of 148. Sine 148, because I know my angle. The sine of 148 gives me about 0.53. I cannot put that back into a fraction, I don't think, but I at least get 0.53. So if I look at sine of 148, I get 0.53. If I looked at cosine of 148, that's going to give me a different value. So cos of 148 gives me 148. Gives me an answer of negative 0.848. So about negative 0.85. Let's go that. Negative 0.85. So negative 0.85. So if we think about where, oh, and they wanted it to 4 decimal places. We just did 2. So if we think about this, 148 is going to end right here. Now, the reason I did sine and cosine is because if you think about your unit circle, cos is your x value, sine is your y value. So this would give you a point value of negative 0.85 and positive 0.53 for your angle here. So that's another way. If they want us to find the point and they give us the angle, we can just use that to figure out our values as well. So same with this, they've given us the point where angle is made by the positive angle. So I can find, there's a couple ways you can do this. Again, I could just plug my value in right here. So the negative 0.8829 and 0.4695. I want to find the angle. So I want to find this angle here. So I can set up my tan here because those are the values I have. Tan is y over x. So 0.4695 over x, which is negative 0. Or we're going to use it as a reference angle. So 0.8829. We're going to second tan that. So second tan of 0.4695. 0.4695. 4695 divided by, we'll do tan of our other one, so 0.8829. 0.8829. And that gives us an angle of about 28 degrees. So once we have that, we have our reference angle. We know that our angle here is 28 degrees. So again, second tanning that, or our tan inverse of the 0.4695 and the 0.8829 gave me 28 degrees. So once I know that, I can just find my standard angle. So 180 minus 28 gives me a standard angle of 152 degrees. Although they also, I think they just wanted here for 28 degrees because they say the positive x. Nope, that is the right one. They just did a really wonky way of saying standard angle. So for our last page here, we now have these two methods. We can use the unit circle or not. If you forget what the unit circle is again, remember you've got this. It goes 1, 0 here. It goes 0, 1 here. And then we have our 3 points values. They're all over 2 for our points. So 2 and 2. And then we count down. So, or count up 1, 2, 3. Count up 1, 2, 3. Put everything over or under the square root. This is 60, then 45, then 30. And then for our tans, we have root 3, 1, root 3 over 3. And then you just need to remember your cast rule. So cast, C-A-S-T. So looking at that, cos of 300 has a reference angle of 60, and sine 330 has a reference angle of 30. So going to cos at 60, I have a half. I'm in the fourth quadrant, so cos is positive, so that gives me a half. Sine of 330, so the reference angle of 30 gives me a half, but I'm in the fourth quadrant, so that's negative a half. This answer works out to 0. If I do 225, my reference angle there is 45, and my reference angle here is 45. So reference of 45, and I'm in the third quadrant, so I'm going to have the negative root of 2 over 2. That's going to be squared because it's sine squared here. And then this one's going to be the same thing, so negative root 2 over 2 squared. So that gives me 2 over 4 plus 2 over 4. This gives me 4 over 4, which is 1. And then for my last one here, 50 has a reference angle of 30. So going through this one, I'd have 30 degrees for 10 is root 3 over 3. So 2 times root 3 over 3 divided by 1 minus root 3 over 3 squared. So I'm going to write this a little differently. So 2 root 3 divided by 3. And I'm going to divide that by this, which is 1 minus 3 over 9. So given this, then I'm going to see if I can move my unit circle here out of the way. There we go. Move it to the other side of the page. Just going to run out of room here. So once I do this, now I have 2 root 3 over 3. 1 minus 3 over 9 gives me 6 over 9. And then remember to do fractions. We keep the first one the same, switch to multiplying, and flip the second one. So then doing this, I'd have 18 root 3 over 8, or 18 root 3 over 18, and that works out to root 3. So that's what I have for my last answer there. So those are my exact values for all of those. Practicing more with the unit circle, you can use, again, the unit circle for everything, or you can memorize special triangles and use them for everything. That is your choice.